Welcome back, everyone. So in this video, we're gonna actually go through an entire free response section for the AP Pre-Cal exam. So what I have here is just some practice and mock AP FRQs that we're gonna go through. So just FYI, this is kind of the format that you're gonna expect to see on the AP test. I kind of spaced out the prompts a little bit more, so if you wanted to, you could actually write your responses within these blanks. However, I do want to show you the document that you're going to be expected to fill out when you are actually in the AP Pre-Cal exam. So your responses, as far as I'm concerned, or as far as I know, your responses for the FRQ are going to be displayed to you on your screen digitally. So whether you're on a laptop, whether you're on an iPad, and then you're going to be recording your responses in a little booklet that will be sealed and sent off, and it's going to look something like this. So your answers for FRQ number 1 will be filled out and completed on this page, and they're going to correlate to a certain question and a certain part. So you'll see all these different parts that you're gonna have to be filling out. Now, another important note is you have to use either a wooden number 2 pencil, or you can use a pen with black or dark blue ink. Anything else, you run the risk of your scores being canceled or void. So keep in mind with your free response questions, you can only write your answers within the confines of these boxes. Anything written outside of these lines will be ignored and will not be considered. And you are not going to be allowed any additional scratch paper. You have to write your entire responses with your work and relevant steps within the confines of these text boxes. So this is what you're going to have on FRQ number 1, then you're going to have on FRQ number 2. So each of these text boxes should be more than enough room for the responses that you're going to be expected to fill out. So once again, this is going to be in a booklet that will be given to you, and then it will be sealed and then sent off to be graded. So for the purposes of this video, I'm not actually going to use this document just because I'm going to be using a flare pen, which is going to be writing a little thick. But when I use a pen or pencil, honestly, like the many times that I've done it, it's plenty of room, so you should be fine. All right, let's go ahead and get started. So looking at this first one, so once again, this is just a mock-up of what you could expect to see. I have different forms and variations of the practice sets. I have 3 in total, but you can probably find more online. So just getting started. So the graph of the function f is shown above and consists of 4 line segments. So we are given a piecewise function, and then the function g is given by this quartic function here. So for question number 1, part A, subsection I, the function h is going to be defined by h of x equals g mapping to f of x equals g of f of x. Find the value of h of 3 as a decimal approximation. And say that should say or indicate that it is not defined. So I even kept the wording that you're going to see on the AP test. Okay, so let's go ahead and get started. So additionally, question number 1 and number 2, you can use a calculator. So I do have my calculator over here and it's ready to go. So I'm gonna go ahead and just do these responses over here. Okay, so part A, subsection I. So the function is defined by the composition, so I know h of x is gonna be the composition of g of f of x. So we want to find the value of h of 3. So h of 3 is going to be equal to g of f of 3. My pen's already dying. We're off to a great start. Let me get a backup one just in case. Everything's going perfect. This is why you always have backups. Okay, so I'm going to start with just f of 3. We're going to start on the inside and then work our way out. So the function f is referring to this graph up here. So I want to find when my x value is 3. So the first thing I need to define is going to be f of 3. And then that's going to be from the graph. So if I go to an x value of 3, that corresponding y value is going to be 1. And then that's what I'm going to plug in for g. So when you get here, now we're going to plug in the 1 value into my g of x function up here. So this is where you're going to want to use your calculator unless you absolutely want to do it by hand, but you're only going to have 30 minutes for the first section with a calculator, which is question 1 and 2. And you're gonna have 30 minutes for section 2, which is questions 3 and 4. So what I'm gonna do is, just to make my life a little easier, because I'm probably gonna have to use this function a few times. So 1.25, I'm gonna go to graph, not squared, to the 4th, plus 2.125x cubed minus 2.8x squared minus 4.8x. So I'm gonna plug it into the graph, I'm gonna go ahead and draw it. I can see it, I'm gonna zoom out a little bit, get myself a little bit of a better view. I wanna find what it's gonna be at 1. So I'm gonna do shift G-solve and then a y-cal. So plug it in when x is 1, and we get a y value of negative 4.225. So that would be your response for this first one. Now, when you find your responses, you're not going to box or circle them. If you box or circle your answer, your grader is gonna be forced to only read essentially this one part, and we're not gonna look at the other parts. So leave your response just like this. This is easy to follow for any grader. So leave it. So now for part 2. So of course you're not gonna have to do the a sub I whatever that I'm doing. I'm just doing that to keep track of where my responses are. So find all the values of x for which f of x equals 2, or indicate that there are no such values. So once again, f of x is gonna be the graph up here. So I wanna know when it's gonna be equal to 2. So this is the same as finding when y equals 2. So what I'm gonna do up here on my graph is I'm gonna draw the line y equals 2. And you can mark all over the responses as much as you want. Well, it's actually gonna be on your computer screen, please don't mark on it. But you can draw it if you need to. So I wanna find all the x values. So that's going to happen at x equals 1, x equals 4, and x equals 8. I'm looking for all the times it crosses that horizontal line. So all I need to write here is gonna be x equals 1, then x equals comma 4, and 8. And that's all you're gonna have to write for that one. Okay, so now for b sub I. So you wanna find all the real zeros of g, or indicate that there are no such values. So this is also why I went ahead and plugged that function into the graph. So what I wanna find are all the zeros, which means I wanna find all the x-intercepts. So emphasis that it said all the real zeros. So I just want the x-intercepts. So on my graph over here, I'm gonna go shift G-solve and then root. Now don't forget, you have to label all of them. So we have a root at x equals negative 1.6, then 0, and 1.5. Now the order doesn't matter, as long as you list all 3 values in the correct notation, you should be fine. Now when I say correct notation, you could list them off just like I did here, or you can write x equals negative 1.6, x equals 0, x equals 1.5. That is fine. Okay, now for the next part, now you're gonna determine the end behavior of g as x increases without bound. Now notice here how it only says increases without bound. I'm not gonna write the behavior as it decreases, only increases. So, and then you are gonna be expected to write it in limit notation. So meaning, this is b sub I2. So for your limit notation, if I look at my graph here, notice how it's gonna be going up and up. So if I look at my polynomial, if you think back, this is a positive and even function. So my function here, it's positive with an even degree, which means my end behavior is gonna go up and up on both sides. So my limit notation as it increases, so I'm gonna say the limit as x is approaching positive infinity of g of x is gonna equal infinity, since it's gonna go up. Now, very important note, make sure you're writing the correct letter here, and then make sure you're going in the correct direction based on the context of the problem. If you even write the wrong letter here, you're not gonna earn that point. Each of these problems is gonna be worth 1 point. You either get the point or you don't. Writing the wrong letter here would mean you don't get the point. So teeny tiny little mistakes like that, they matter. So now looking at part C. So C sub I. So we're going to use the closed interval of negative 1.2 to 1.8 to answer the following. So we're going to determine the absolute minimum output value of G, and you're going to label it appropriately. So we want the absolute minimum output. So this output refers to the Y value, which means over here on my calculator, I'm going to limit my window on my calculator to just this interval. So what I'm going to do, shift V window, and I'm going to go from negative 1.2, whoops, I can't type, sausage fingers, 1.2 to 1.8. So when I do that, I'm going to press exit and then go back to draw. Now you need to make sure that your graph is going to go off to the left and then off to the right. If your function goes off the top or off the bottom, then you need to adjust your Y values. So my Y min, I'm going to say negative 15, and my Y max, I'm going to say 15, just to give myself some wiggle room. So now it's going off to the right, and now it's going off to the left, so now I'm good. So what I want to find is going to be the minimum output. So what's the lowest that this function is going to go on this interval? So I want to find the minimum. So shift G solve and then minimum. So our Y value is what we want because we want the output value. So I want negative 4.247. I already would have lost that point right there. So Y equals negative 4.247. So this actually brings up another good point. If I were to write X equals negative 4.247 and you're like, oh crap, I'm in pen, I can't erase that. On the AP test, what you can do is you can just cross it out. But I would make it clear that you're crossing it out. Because if it's not crossed out and you know that that part is wrong, they're gonna look at it and they're gonna consider that. So if you do have a mistake and you need to cross it out, make sure it's obvious that you're crossing it out. So now looking at C sub II. So now we want to determine the absolute maximum output value of G. So maximum output, we're still looking at the Y values. So now you want to label the answer appropriately, of course. So when I look at this graph here, I can see that the highest point on this interval is actually going to be this endpoint way over here. Now, if you look back at the interval, we can include those endpoints. So that means I need to find the value at that endpoint. So if I try to do a maximum, it's not going to give me that endpoint. It's going to give me only the relative within the interval. It's not going to actually give me this endpoint. So what that tells me is I know I need to do a YCal at 1.8. So shift G solve and then a YCal at 1.8. And there's going to be your maximum. So Y equals 7.803. So these would be, hopefully, your responses for question number 1. All right, let's move on to question number 2. And I'm gonna also get a different pen because this one is dying on me. Okay, so number 2, once again, we can use a calculator on this problem. So social media app TikTok was released to the public in 2016, has had incredible growth patterns since 2020, which we're gonna say is gonna be T equals 4. So TikTok reported 465.7 million users. And then in 2024, where T is equal to 8, TikTok reported 900.7 million users. So the number of users of TikTok can be modeled in the function U given by U of T equals AB raised to the T, where U of T is the number of users in millions T years after release. So for this first one, we want to use the given data to write 2 equations that can be modeled to find this data. So what we're going to start with so I'm going to use in the year 2020, where T is equal to 4. That means we're going to have 465.7 million users. And then in the year 2024, this was the 8th year. And then this was 900.7 million. So what you're gonna do is we're gonna use the model u of t equals ab raised to the t. And we're gonna plug in this information. So we wanna write two equations in this form that represent this data. So we're gonna have the t values and then our output values. So my first equation, we're gonna have ab raised to the fourth is gonna be 465.7. And then my second equation is I'm gonna have ab raised to the eighth, and that's gonna equal 900.7 million users. So this would be your response for the first part. And then in the second part, now we're actually gonna find the values for A and B. Let me actually get another piece of paper so it doesn't bleed through underneath. All right, so now, I'm gonna use these two equations to actually find my A and B values. So what I'm gonna do is I'm actually gonna start with the bigger equation. Well, I say bigger equation, but the one with the higher degree. So I'm gonna take my AB to the eighth equals 900.7 million. And then what I'm gonna do is I'm gonna modify this equation so that I can actually plug in this information over here. So meaning I'm gonna manipulate the left side to be AB raised to the fourth times B to the fourth. And that's gonna equal 900.7. So when I do this, I split B to the eighth into B to the fourth and B to the fourth. So now I have AB to the fourth, which I can now plug in this value, and then I can plug it in and then I can solve for B. So then this right here is gonna turn into 465.7 B to the fourth equals 900.7. So now I'm gonna divide both sides by the 465.7. So B to the fourth is gonna be equal to 900.7 over 465.7. And then I need to get rid of the value that's raised to the fourth power. So I'm gonna raise everything to a 1/4 power. So I'm gonna have B is equal to 900.7 over 465.7. And then this number will be raised to the 1/4 power. So I'm gonna do this on the calculator. So I'm gonna go back to run matrix. So I'm gonna do 900.7 over 465.7, and then raise this to the 1/4 power. So my B value, and because I'm gonna round it, I'm gonna do the approximate. So 1.179. So that would be my decimal approximation. And then what I'm gonna do on the calculator so that I don't have to worry about rounding, I'm actually gonna store this value. So I'm gonna press the storage key, and then I'm going to store it in the letter B so I can reuse it. So now I'm gonna come over here, and now I need to kind of quote unquote work a little bit backwards so I can solve for my A value. So what I'm gonna do is I'm gonna come back up here to this first equation. So I'm gonna write AB raised to the fourth equals 465.7. And then what I'm gonna do is I need to solve for A. So I'm just gonna divide by B to the fourth. So I'm gonna have A equals 465.7 over B raised to the fourth. Now I'm not even gonna try to write that number in, I'm just gonna leave it as B to the fourth because I stored it. So I'm gonna do 465.7 divided by B raised to the fourth. So then my A value, when I round, is gonna be approximately 240.787. So that's what you're gonna need for that one. Where is all my paper? I grabbed a whole stack, there it is. Okay, so now we're going to move on to part B. So we want to use the given data to find the average rate of change of the number of users in TikTok in years from t equals 4 to t equals 8. And we're going to express our answer as a decimal approximation. So whenever they say show the computations that lead to your answer, this means, this is their fancy way of saying you do have to show your work, technically. So not showing your work and only showing your answer would result in you not earning that point. So for the average rate of change, so I'm gonna shorthand it as AROC. So I wanna find the AROC from the 4th year to the 8th year. And you have to be very careful that you're using the right letter. So what happens is we're gonna use U of 8 minus U of 4 over 8 minus 4. So I need to find these values. So what I'm gonna do on my calculator, so I'm gonna go to graph. That was for FRQ number 1, I no longer need that. Oh, also just remembered, I did not store that value. That's what I need to do next. So when I try to press the storage, the answer didn't populate, so I'm gonna do shift negative and then store it in the letter A. So now that I have both the A and the B values stored, now I'm gonna go to graph, then A, B raised to the X. And I'm gonna draw it. And then I'm gonna adjust my window because we're gonna need a lot of adjusting here. So let's try 350. Nope. Let's try 600. So I'm just doing trial and error. Whoops, not tangent. Let's just do 1,000. That should work. Okay, so in this case, I need to find the value at 8. So I'm gonna do shift gsolve, then ycal at 8, which is gonna be 900.7. So my AROC is gonna be 900.7, which also I'm being a dum-dum and they literally gave us those values. But I still wanna show you how to do this on a calculator just in case. So I technically just wasted that time when they gave us those values. But you know what? That's what happens when math is hard. Okay, so then I'm gonna just go to run matrix and then just plug in these values. So 900.7 minus 465.7 over 8 minus 4, which is gonna give you the fraction 435 divided by 4, but remember they want the decimal approximation. So I'm gonna press this button here, which means we have 108.75. I made that question way more tedious than it should have been. All right, now for the next part. Now you want to interpret the meaning of the answer. So essentially, what does this number mean? So BII. So remember, average rate of change is going to be linear in nature. So just kind of unofficially, what I do when I show you, I'm actually gonna use this. Nope, no, I'm not. Where is a blank sheet? Here we go. I'm just gonna use this. So whenever we're doing the average rate of change with this equation, what's actually happening is we have this exponential, but then I'm finding the average rate of change between two values. So for example, like we'll say this is t equals 4, and I'm gonna say that this up here is t equals 8. So when I attempt to draw a straight line, notice how it's an over approximation between 4 to 8, but then an under approximation when it's less than 4 and bigger than 8. So notice how it's pretty close in this interval, but then as it gets further along, it's actually going to go further and further away. So this is kind of the information that we want to look at. This is going to help us with the rest of this problem. So what this means is we are predicting, based on the average rate of change, that TikTok will grow by 108.75 million users, each year. So this is what they're predicting based on the average rate of change in this problem. Okay, so now for part 3 over here. So now we're gonna consider the average rate of change on this interval from, let's see if I can read and try to fit all this on here. That's fine. So consider the average rate of change of u from t equals 8 to t equals p years when p is greater than 8. So what this is telling you is just when we're looking at this part of the graph. So are these average rates of change less than or greater than the average rate of change from t equals 4 to t equals 8? So look at your path of the graph. Notice how it's concave up. So when it's concave up, what that means is your average rate of change is going to be increasing. So what you're going to write, or how I will word it, the AROC of u of t from t equals 8 to t equals p where p is greater than 8 will be greater than the average rate of change from t equals 4 to t equals 8. And then we also need to explain our reasoning. So this was just saying that it is going to be bigger. And I'll actually change that to a comma because u of t is increasing and concave up, which means the AROC is increasing. As t increases. So I know it seems like a lot of writing, but interpreting the data and the answers is going to be just as important as the answers itself. All right, now for the next part, I just gave myself a paper cut. This is why you don't do math. Okay, so now for this last part, for part C, so for which t value, t equals 6 or 12 years, should you have a more confidence in when using the model of u? So you want to give your reason for the answer in the context of the problem. So if I refer back over here, so t equals 6 would be about halfway, and then t equals 12 would be like way over here. So essentially it's their way of asking you which one would be easier to predict based on my average rate of change. Well, if I look at the model, t equals 6 is going to be pretty close to the average rate of change based on this drawing. T equals 12 is going to be way further from the average rate of change than t equals 6. So what that tells me is t equals 6 will be a better guess, or more reliable rather. So in this case, what I'm going to say so t equals 6 because t equals 6 is within the interval t equals 4 to t equals 8. So you also want to kind of justify why 12 is not going to be a good fit. So, I mean, if you actually think about recent events, there was a TikTok ban, which means the number of users in TikTok decreased drastically. It actually, I believe, was at 0 at some point because it was just turned off. So, in this case, so t equals 12, I don't know if I like that wording. So rather than saying far off, because that's subjective. So t equals 12 So this is just kind of my thoughts on it. So t equals 6 is going to be more reliable since it's within the interval from 4 to 8, which is what we were kind of working with. T equal 12 would be unreliable as external factors may impact the number of users by the time we get to t equals 12 years. So for example, like the TikTok ban that we had. So I know population is also going to be another common problem theme amongst number 2. Anything that's like exponential growth or decay, or anything that even has like a logarithmic curve, those are going to be common themes for number 2. So that's number 2. All right, so now we're going to move on to FRQ number 3. And when we get here, that also means we are losing our calculators. So I actually might be able to do number 3 on this page, but let's see. Let me grab another pen. All right, let's see how this goes. Oh my gosh, I have too much stuff on this desk. Okay, so on a particularly windy day, a buoy on Grapevine Lake takes 3 seconds to oscillate up and down. The buoy is 25 feet above the lake bed when it's at its maximum height and 17 feet above the lake bed when it's at its minimum height. So the sinusoidal function models the distance between the buoy and the lake bed in feet. I can't read. Where is... Okay, so the graph of B and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, P are shown on the graph. No scale is indicated, no axes are presented, and you want to determine the possible coordinates T, comma, B of T for the 5 points. So on this problem, we're going to kind of take a lot of this information to kind of see what's going on. So they do tell me that it takes 3 seconds to oscillate up and down. So what that tells me is the period is going to be equal to 3 seconds. And they also tell me that the buoy is 25 feet above the lake bed when it's at its maximum. So the max is 25, and then the minimum is 17. It's kind of weird going from a flare pen to a regular pen. All right, now what we want to know is, let's see if they tell us where it starts. So they don't tell us whether it's going to start at a maximum. They don't say it's going to start at a minimum. So because they don't necessarily tell us where the time starts, that means we could technically start at a minimum, we could start at a maximum, we can really start wherever. So what I'm going to do is, I know the maximum is going to be at 25. I'm going to go ahead and just say that t equals 0 is going to start at a max, because we just have to find possible coordinates. So what this tells me is I'm going to say this is going to be t equals 0, and it's going to be 0, 25. Now they also tell me that it's going to take 3 seconds in the period. So I'm going to do 3, 25 for point P, and then halfway between 0 and 3 is going to be 1.5 seconds. So 1.5 seconds, it'd be at its minimum, which is going to have a height of 17 feet. So now I need to find point G and K. So what you can do is, in order to find the x-axis scale, I like to do the period divided by 4. So that's going to be 3 over 4, which is 0.75. So that means I'm going to count on the x-axis by 0.75 seconds. So 0, 0.75 seconds, and then plus another 0.75 seconds, which is 1.5, and then plus another 0.75 seconds is going to be 2.25 seconds, and then plus 0.75 seconds is going to give me 3, so it works. Now I need to find the value of this midline. So in order to find the value of the midline, you can also do the amplitude. So the midline, which is your D value, is going to be the average of the max and the min. So if you're going to do the maximum and the minimum and then divide by 2, so 25 plus 17, that's going to give me 42. Divide that by 2 is going to give me 21. So I know that the midline is going to be at y equals 21. And then I can also find the amplitude, because I'm going to need the amplitude for part B. So the amplitude, which is your A value, is going to be the max minus the min divided by 2. So to go from 17 to 25, that's going to be a value of 8, and then 8 divided by 2, which is going to give me a value of 4. So I know my distance from the midline to the top is going to be 4, and I know the distance from the midline to the bottom is also going to be 4. All right, so now we have our points not labeled yet. So I need to label G, which I'm going to say this is going to be 0.75, comma, the midline, which is 21. And then point K, which is going to be 2.25, comma, 21. So there are my 5 points. All right, now on part B, now I need to actually write an equation that's going to model the scenario. Now you got to be careful and pay attention to the actual sign that we're using in here. So what this means is I am using a positive sign graph. So positive sign, which means I want to start at a middle point before I go up. So that plus sign means we're actually going to take the actual sign of the x value. So if I want to use a middle point before it goes up, I can use this point over here, or I can use point K. It doesn't matter which one. If I use this point over here, this would be t equals negative 0.75. But we can really use either one of these. So my a value, which I already solved for, we know is 4. My b value I do need to solve for. So b is going to be 2 pi divided by the period. So I know the period, based on the beginning, we said was 3. So this is going to be 2 pi over 3. And then my c value, you do have multiple options for your c value. So you can either use negative 0.75, or you could even use 2.25. It doesn't matter which one we use. And then your d value is going to be your midline, which is 21. So I just need to put all this information together. Now there's multiple different potential solutions for this. You just gotta pick which one you wanna use. So I'm gonna go ahead and just use the negative 0.75. Okay, so in this case, we're gonna have, b of t equals 4 sine, and then my b value, which is 2 pi over 3. Okay, and then I'm gonna do my t value, and then we're gonna do minus 0.75, and then plus 21. So that could be one of your equations. All right, now we're gonna look at part C. So refer to the graph of B in part A. So the t-coordinate of F is gonna be t of 1, so we're gonna look from F, and then we're gonna go until G. So we're looking at just this little part of my graph right here. So in this case, we're looking to see whether it's positive or negative, and then increasing or decreasing. So the positive negative is gonna refer to the y value, and then the increasing decreasing is gonna refer to the direction. So if I look at my y values, I have a positive 25 to a positive 21. So my values for sure are gonna be positive, so I know it's not negative. And if I look at the direction of my graph, I'm going from 25 to 21. That means it's gonna be decreasing. So we are gonna be positive and decreasing. So on that answer, you're literally just gonna write the letter B. That's all you're gonna have. All right, and then for this last part down here, you're gonna describe how the rate of change of B is changing on the interval from T1 to T2, which means we're gonna refer to the same values that we used in this previous problem. So the average rate of change, we're looking at the concavity. So if I look from F to G, it's concave down, which if it's concave down, that tells me the AROC is gonna be decreasing. So B of T is concave down. From T1 to T2, which means the AROC, is decreasing. Ta-da. All right, number 4. So once again, another one that is no calculator. Now, this question specifically is gonna have all the, what's it called? Directions and like kind of important rules that you have to abide by. So I'll let you guys take a minute and I'll let you guys read all this. This is gonna be copy and paste on the AP exam. All right, so starting off, part A. So the functions g and h are given by these two equations. So g of x is gonna be equal to log base 4 of x plus 5. So for a sub I want to find where g of x is equal to 2 for all the values of x in the domain of g. So I'm going to take my equation, so log base 4 of x plus 5, and I'm going to set that equal to 2. And I'm going to solve for the x value. So with this log equation, remember your logs can't be 0 or negative, which means we have to have a value that's greater than negative 5. So I know for a fact, x has to be greater than negative 5. So now when I solve, I'm going to do circle of life. So I'm going to do 4 raised to the second power is going to equal x plus 5. So x plus 5 is going to be equal to 4 squared. So x plus 5 is going to be equal to 16. Subtract 5 on both sides, so x is going to be equal to 11. So that's all you need to do on that one. So now for a sub I. So now we're going to take that equation and we're going to set it equal to 1. So I'm going to have 2 cosine squared of x, and that's going to equal 1. And we want to find it on the interval from 0 to 2 pi. So notice how it's not all possible solutions. All right, now in this case, I'm going to divide both sides by 2. So cosine squared x is going to be equal to 1/2. And then I need to take the square root of both sides. So cosine of x is going to be equal to plus or minus the square root of 1/2. Now, when you get here, this is the same as writing 1 over the square root of 2. So in this case, we are going to have to rationalize. So when I rationalize, come up here. So cosine of x is going to be equal to plus or minus root 2 over 2. So what you're going to have to do to rationalize is multiply by root 2 over 2. So over here, this value right here, the root 2 over 2, is going to be on the unit circle. So I want to find the values where cosine is equal to negative root 2 over 2, and find the values where it's equal to root 2 over 2. So this is going to happen at your pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we want all 4 of those values. All right, now looking at the next one, so part B. So the function j and k are given by the natural logs up here, then we have this trig expression up here, or equation rather. So for part B, you want to rewrite j of x, so if you can't see anything. So we want to rewrite j of x as a single natural logarithm without any negative exponents in any part of the expression. And then your form should be in the form of natural log with some sort of expression inside the parentheses for the argument. Okay, so let's go ahead. Let me write it down, then I'll move it up. So we have natural log of x plus 3 minus 2 natural log x minus 3 natural log of x minus 2. So we just want to simplify this, or rather we want to condense. So hopefully, if you remember, your coefficients in your logarithms are going to jump and become exponents. So this is going to turn into natural log of x plus 3 minus natural log of x squared minus natural log of x minus 2 cubed. And then what's going to happen, if your value is positive, then we're going to write it in the top of your logarithm. So the natural log of x plus 3 over here, this is positive, so this is going to go in the top. But the natural log of x squared is being subtracted, it's negative, so this is going to go in the bottom. And then we're subtracting the natural log of x minus 2 cubed, so this is also going to go in the bottom. So when I am rewriting, this is going to turn into natural log of x plus 3 And this is going to be over x squared times x minus 2 cubed. And that would be your condensed logarithm. So now for the next one. So we want b sub I. So you're going to rewrite k of x as an expression which cosine appears once and no other trigonometric functions are involved. So this is going to be your trig identities. So I'm going to have sine squared of x over 1 minus cosine of x. So also notice how on these problems, they're not going to give you log properties. They're not going to give you any of your trigonometric identities or any equations like that. You got to know everything. There are no formulas that are going to be provided to you. So in the top, sine squared x, I'm going to rewrite this in terms of cosine. So I can rewrite that as 1 minus cosine squared x over 1 minus cosine x. And then when you get here, I notice that 1 minus cosine squared x is technically a difference of squares. So I'm going to rewrite it as 1 plus cosine x and then 1 minus cosine x. And then that's going to be all over 1 minus cosine x. So you could put this in parentheses if you wanted to. Now notice how 1 minus cosine x is going to be in both the top and the bottom. So then when those simplify, all we're left with is 1 plus cosine x. So this would be your answer. You're not going to have to rewrite the 1 in terms of cosine. It would just simplify it back to this anyways. So the 1 plus cosine x, this would be your final answer. All right, and last but not least, so the function m is given by m of x equals cosine 2x plus cosine x. Find all input values in the domain of m that yield an output value of 0. Now notice over here, it's kind of subtle, but it is very important. It says find all output values. This means find all possible solutions. So for C, so I'm going to be given the equation m of x, and this is equal to cosine of 2x plus cosine x. And then I want to find all the values that are going to give me an output value of 0. So I'm going to set this equal to 0. So cosine of 2x plus cosine x, and that's going to be equal to 0. So once again, no values or anything are going to be given to you. You just got to know your trig identities. So cosine of 2x, let's see, I can write this in terms of cosine squared x minus sine squared x plus cosine x. And then I notice how I have 2 values of cosine and only 1 value of sine, so I want to rewrite the sine in terms of cosine. I want to get it down to just 1 trig function if possible. So I'm going to rewrite, so cosine squared x minus, and then 1 minus cosine squared x plus cosine x equals 0. So now I need to distribute that negative. So cosine squared x minus 1 plus cosine squared x plus cosine x is going to equal 0. And then I'm going to combine like terms. So I have cosine squared x and cosine squared x. So this is going to be 2 cosine squared x plus cosine x minus 1 equals 0. So this is going to turn into factoring a quadratic. So you can leave it in terms of cosine and factor it this way, or you can do a substitution if you want. So meaning like if you want to do n equals cosine x, so this would turn into 2n squared plus n minus 1. And if you want to factor this, then you can. So when I factor this is using factoring by grouping. So 2 times negative 1 is negative 2. Factors of negative 2 that add up to a positive 1. So that means I want 2n squared plus 2n minus n minus 1. So then when I factor, so factor out a 2n in the first group, which is going to leave me with n plus 1. Factor out a negative n, probably should have done the grouping. So in the second group, take out a negative, and then we're going to have n plus 1. So we have n plus 1 and n plus 1. Those are the same, so I'm good to keep going. So we have n plus 1, and then we're going to have 2n minus 1 equals 0. And then I'm actually going to put these values, or put my cosine value back in. So I'm going to come back over here. So I'm going to have cosine x plus 1 equals 0. So this is going to be my first set. So when I solve, I'm going to have cosine x equals -1, which that's only going to happen at pi. So not 0, just at pi. If it was at 0, it would be a positive 1. So my next equation would be 2 cosine x minus 1 equals 0. Then this would turn into cosine x equals positive 1/2, which that is going to happen at pi over 3 and 5 pi over 3. So because I want all possible solutions, so I need to do x equals pi over 3 plus 2 pi k, where k is an element of the integers. And then I'm going to do k is equal to pi plus 2 pi k, where k is an element of the integers. And then x is equal to 5 pi over 3 plus 2 pi k, where k is an element of those integers. So this would be what we're looking for. So I know this problem is probably the most involved, but it's still doable. I think the hardest part, in my opinion, which I know doesn't mean much coming from me, I think the hardest part is just getting it to fit in that space. But hopefully this was helpful. Make good choices,